Welcome to our virtual code club. I'm Nicola from Code Club Australia, and today we're going to be doing some fun coding, and we have a special guest here, Jack, who works at Microsoft. And before we get started, I'd like to thank you for joining and also acknowledge the traditional owners of the land that I'm on. I'm in Sydney, which is the lands of the Gadigal people of the Eora Nation. And I'd like to acknowledge leaders past, present and emerging. So thank you so much for joining. So I'll pass over to you, Jack.
Thanks, Nicola. Now, the way my screens are set up here, I can't see chat all of a sudden. So if you've got questions, Harvey and Parker, put them into the chat and Nicola will read them out to me. I will kick this off. So thank you so much for having me. My name's Jack and I work for Microsoft. We build tech. You might have built things like spreadsheets or PowerPoints before. And that's not really that exciting, but we also build things like the HoloLens for holograms. We build things like Minecraft and we make the Xbox. So in my work, I get to play with lots of really cool tech and computers. And today, I'm going to help you understand how machines think. You might have heard about things called machine learning and AI. Maybe you've played against a bot in a game before and it's leveled up and gotten better as you get better. I'm going to help you understand how that works. And then as part of the coding session, we're actually going to make our own AI at the end of it. So there's two things I want to take you through. The first is going to be how to teach machines to see. Because Nicola, you and I have eyes. We all have eyes. We can see the world around us, but machines don't. And this presents a problem when you're trying to teach a machine about the world around it. So we start with images, maybe from a camera or a webcam or just photographs. And we teach the machine to recognize patterns in those images. So here's a quick challenge for you. Nicola, what letter is this?
I think it's an A.
That's a good guess. How confident are you that that's an A?
100%.
Okay. And why do you know that's an A?
I guess because I learned at school that that's what an A looks like.
Absolutely. We as humans, we've spent years and years recognizing the shape of the letter A. So we could also know that all of these are letter A's as well. Now, this is really fundamental, boring stuff, right? We all know the letter A. But it's really important for a machine to have to learn this as well. So the next thing I want to talk you through is confidences. You know, how certain are you that this is a letter A? What happens, for example, if we have a whole lot of different letters? A's, D's, Q's, they all look a little bit similar. And I can remember when I was learning some of my maths, some of my alphabet, I struggled to recognize certain letters when I was learning my spelling and things. So the way we teach a machine how to recognize these characters is we take all of those photos, all of those images or the video in here, different letters, and we go through a manual process to identify them, to actually say, these are letter Q's. The machine doesn't really know what a letter Q is, but it knows that it's something and it looks like this. And then we go through and we identify the letter D's. What does a D look like? And then again, the same thing with the letter A. And this is the same thing that we did when we were learning our alphabet growing up. The machine has to do it too. Now, the way the machine guesses things that it's learned is it takes that sort of model that we've taught it about what A's look like and Q's look like and D's look like. And so that when we ask the computer, how confident are you that this is a letter A, it can actually tell us. I'm 95% sure this is a letter A, but it could also be a D and it could also be a Q. The computer doesn't have this perfect, absolute example of the world around it. It has sort of a guessing game of sorts with these images. So in this example here, what we would do is we'd say, well, the best guess is an A. It's 95% certain that this is correct. So we're going to say that this is a letter A. Now that's great for images or maybe for numbers, but I've got a challenge for you, Nicola. Can it work for images? Do you know who this is?
Oof. Only because I used to watch a lot of this show when I was a kid, and I think that's Lisa from The Simpsons.
It is indeed Lisa. Lisa is my favorite Simpson. And I wanted to show you this because this sort of pattern recognition, where we see lots of an image and then we start to recognize it, is absolutely true for people, for faces, for buildings, everything in the world around us we can start to recognize through this process. We know that from watching a lot of The Simpsons and a lot of the animation. We see different shapes of what Lisa looks like, and we notice the pattern of her hair, that spiky outline, her necklace that she wears. So it works for images as well. And this is how a machine gets to understand the world around it, how it can see. It doesn't have a brain, so to speak, like we do, but it thinks in a similar way of recognizing those patterns. So, second thing I want to teach you is how do we teach machines to think? Because if a machine can understand some of the things we're showing it through maybe a webcam or a video, we need to be able to teach the machine how to understand, critically think about what to do with that. And this is where I get to talk about training dogs. Now, Nicola, do you have a dog?
Sadly, not.
Have you ever trained a dog? Given it a treat to sit?
Yes,
walk? Yep.
I'm training my neighbor's cat.
You're training your neighbor's cat. That's fantastic. I love dogs. And I remember when we were training my dog, Chino, we'd have to teach her to sit, to stand, to walk, to stop, maybe sometimes to speak. And we did that by having an action, teaching Chino, our dog, whether or not that was a good or bad thing to do. And the way machines work is that we can also teach them based on a score, right? So an example of this could be to sit. And so we give our dog our sit command, and that's a good thing to do. So we're going to give our dog a +1 as a scoreboard. Maybe the dog ignores our sit command. And so we take off points for that because the dog didn't do what we said to do. And if the dog runs away across the road, that's really bad. So we -1 point on the scoreboard. Now, we know this, right? I do it for myself. When I do my work for the day, I reward myself with a cup of coffee or some chocolate. It works for our brains because it reinforces the things that we should do in our daily life. It's exactly the same for computers. We constantly go through a process of teaching the computer what to do. For example, sit, stand, walk, and then reinforcing whether or not the result of that was good or bad. And that's where the score comes in. Now, here's the tricky thing. How do you know if something is good or bad? What if we were to teach our dog to bark on command? Might be fun sometimes, but I bet your mum and dad's not going to be thrilled. And so this is where machine learning is a little bit tricky because we can teach the computer to do bad things. Just want to let you sit there and think about that for a moment because we have a responsibility to build really good AI. So I've taken you two things. We've learned how a machine can see the world around it by recognizing patterns. And then we've taken this idea of good or bad sort of scores to reinforce good behaviors. These are two really important principles with AI and with machine learning. Well, that's all well and good, Jack, but how do I use it? Where are we going to have some fun with this machine learning? Well, the team in Australia that I work with built a really cool pinball machine. And I want to show you how that pinball machine works using those two things, teaching a machine to see and then reinforcing good or, maybe penalizing bad behavior. So this is the machine. It does work. It can play itself and then you can play it. So if you've ever gone to an arcade or the movies and you've seen a pinball machine, this is a stock standard, nothing special about it machine. We haven't modified it at all. What we have done though is add some cameras so that the machine can see the pinball machine. In fact, let me show you this video. So you can see the pinball machine is playing. It's got a high score that it's ticking up. And then it's learned how to hit the flippers at the right time. And if I pause this video here, just for a moment, you might be able to see that it's got a score. And the reward is, 0.1. And then when it loses the ball, it's got a reward of -1. So we said, hey, you shouldn't have lost the ball. You should have hit the flipper. So we're going to lose some points for that. And then the way this machine works is that we let it play for days and days. And it plays lots of games and it gets lots of rewards when it hits the ball properly. And then it loses lots of points when it misses the ball. This is the fundamentals of how we build machine learning. So let me skip forward and I will show you this here. So on the far right-hand side of this screen, you can see I've circled a little camera that is pointed at the scoreboard. Now, you remember in the very beginning of my talk, I explained how we were identifying Ds and Qs and As. Well, the computer's doing something similar for scores. In this exact photo, you can see a 7 and a 4 and a 0 and all the other numbers on the high scoreboard. This is how this pinball machine understands if it's got points or not, and we can give it a reward as a result. The next thing I'll show you is a camera at the top of the pinball machine. So it can actually see, and you can see on the right-hand side what the machine sees. You can see the board. So it can see where the ball is moving around and to hit the flippers. Together, all of these things combined means the pinball machine is able to learn over time how to play pinball. Now, we didn't have to write any code that said, here's how to hit a flipper, here's when you should hit the flippers. All we did is say, you can hit the flippers and we'll give you some scores based on it. And you can look at the high score and the board. And so just like us learning to play any new game and we've got to learn the rules, so did the machine. And it did so by looking at the score and getting, a reward or a penalty for how it plays pinball. So I'm not sure if we've got any questions, or Nicola, if you've got any questions. Hopefully you enjoyed that little showcase of a machine learning pinball machine. I still geek out about this, that the team built it. And I'm really happy to answer any questions, or we can jump over to Scratch and build something fun.
Cool. Thanks, Jack. I do have a question in the meantime. Did anything weird go wrong with the pinball machine? Did it do anything that was surprising?
It did. It's funny enough, the lights made a difference. So if you think about a pinball machine, it's got a big sheet of glass over the top of it that protects the board. And if you've got lights in the ceiling, they will reflect off that glass. One of the first times we built the machine, my colleague in Perth had rolled it out. He'd spent the whole weekend watching this machine learn to play and built up that model that I was talking about where it learns to play the game. But because the lighting had changed, it looked like the reflection off the glass was the ball in the pinball machine. And so because we hadn't given it enough variation in that model, it just sat there going, but the ball isn't in play, and kept losing the ball, right? And so lots of little things like that, we didn't expect to encounter that. We learned it by trying things and then understanding what had gone differently. And so, yeah, there's lots of things with this pinball machine that we've learned over the last year. And my team are still working on, writing up and learning more about the pinball machine, even now, a year after they built it.
Cool. That's awesome.